Hey folks, how's it going? It's Mr. Murray, and I'm welcoming you back to another really great week of math. I really hope you enjoyed April break. You found it relaxing, and you took some time to make sure you're spending time with yourself and your family, kind of you know doing what you can to cope with this unusual situation. As you know, we're not going to be going back to school for the rest of the year. And so I'm trying my best to help get you ready for what's going to come up next year. And so hopefully this, continues to be a really great experience and you guys continue to put in a really strong level of effort. So we're going to jump back into our investigations around circles. Okay, leading up to break, we talked a little bit about trigonometry. Right, we spent a lot of time with law of sines and law of cosines. We took that little trig test. It feels like forever ago, right? And then we started with circles. We investigated arc length and sector area. Okay, and if that's something that you're a little bit fuzzy on, I encourage you to go back and take a look at some of the videos that I posted in the later part of last week. So what we're going to do today is I need you to do a few things. I need you to find, for this do now, the area of the purple region, and this is this little sliver between the hypotenuse of this triangle and the circle, so this little sector. Okay, I need you to find the red region, which is the entire sector, starting from here and including the triangle and the purple region. And then just the blue region, just the triangle itself, okay? So you need to find those three areas, and I need you to report them in two ways. One, where you leave any pi in your answer if that's applicable. It might not be, but if it is, leave pi in your answer. And then also provide an approximate answer rounded to the nearest hundredth. Okay, so again, what we're doing is pausing the video, finding the purple, which is just that little sliver, the red, which is the sliver and the triangle, and the blue, which is the triangle. So pause the video, find that area with pi and rounded, and then when you're ready, unpause, and I'll show you how to solve it. All right. So remember, leading up to break, what we learned is this. We started with the fact that the area of a circle is equal to pi times the radius squared. And the circumference of the circle is equal to 2 times pi times the radius. Now, what we learned is that for any given sector, any given slice out of this pie, so to speak, the ratio of the angle, the internal angle, to 360, which is the entire, 360 degrees, is equal to the ratio of the area of the sector to the entire area of the circle. So for example, here we have 90 degrees out of 360 is equal to 1/4. So because this angle measurement, the interior angle measurement of this sector is 1/4 of the total angles of a circle, this area is 1/4 of the total area. Okay, we also know that because area is pi r squared and the radius is 4, the area is equal to 16 times pi, because it's pi times 4 squared. So the red area is first, the area of everything. The area of everything is equal to 1/4 of the area of the circle. Because it's 90 is 1/4 of 360, the area is 1/4 of the total area. So that's equal to 4 pi. Okay, remember I use 3.142. It's kind of a quirky thing I do, and I do that just for a little bit more accuracy. You can use the pi button as well. I'm going to do 4, because by the way, 4 is 1/4 of 16, and I got 12.57. Okay, and I use 3.142. If you use 3.14, you'd get 12.56. If you use the pi button, you'd get 12.57. So, you know what I mean? It's not off by a lot, but I just want to show you that you do get a slightly different answer. Okay, area of the blue. Now, the blue is just a triangle, and it's a 45, 45, 90 triangle. I know this Well, essentially because these are both radii, so the radii must be the same length. So this is also 4 centimeters. So it's 1/2 base times height. So it's 1/2 of 4 times 4. So it's 1/2 of 16. So it is 8. Okay. And by the way, we should be reporting these in centimeters squared. Okay, this is centimeters squared. So now the area of the purple. To get the area of the purple, we take everything, the red, and we just subtract out the blue. So the area of the purple is equal to the area of the red minus the area of the blue. Okay, and the area of the red is 4 pi, and the area of the blue is 8. Okay, so it's 4 pi minus 8, which is approximately 4.57 centimeters squared. Okay, that is the area of the purple. Because if you think about it, the purple is like I notice if you look at where like the shading here, right? The red and the blue overlap. The red and the purple overlap. But with the exception, and this is just more my poor drawing than the reality here. So if we technically were to go in here, we were to fix this up, okay, and we were to go in here, and we were to clean this up a little bit, okay, the idea that I'm getting at here is that the red and the blue overlap. The red and the purple overlap. The red and the blue overlap. But notice the purple is like the red without the blue. So it's the red, everything, take away the triangle. All right, so hopefully you're able to get this right. Again, our answers are 4 pi for the red, 8 centimeters squared for the blue, the triangle, and then about 4 pi minus 8, or 4.57 centimeters squared for the purple. So again, hopefully you're able to find this video to be helpful. Hopefully you're able to get this right. I got plenty of activities for us to jump into today to help us get back into the swing of things. Keep things up. Don't forget to love math. And remember, you can do it. Okay, thanks for watching. I'm already looking forward to seeing everyone on Wednesday. Have a wonderful day.